All right, 4.4, we're going to continue taking the derivative of things, but we're going to learn a new strategy on taking the derivative. So that is the chain rule. So if we have something, if we have parentheses, something inside the parentheses with an exponent, we can't just take the derivative straight up. We have to use the chain rule. So one way that we can think about it is we can use substitution where we're going to make the inside u. So I'm going to say u equals 3x squared minus 4. And then that way, y equals u to the 100th power. So I just substituted u into the parentheses. So now we're going to take the derivative, which typically our derivative would be dy over dx, the derivative of y with respect to x. But now instead we have a u in here. We're going to take the derivative of y with respect to u and then multiply it by the derivative of u with respect to x. So we're just going to take the derivative of both of these things and multiply them together. So dy over du would be the derivative of y. So y prime. What would be the derivative of y here? If we have u to the 100th power, what's the derivative? 100 times u to the 99th power. Now we're going to take the derivative of u, so I'll call it u prime. What's the derivative of 3x squared minus 4? 6x. Perfect. Now we're going to multiply these two together. So 100. I'm going to substitute u back in. So what did we say u is equal to? 3x squared minus 4, so that's going to get substituted back into u to the 99th power times 6x. So we took the derivative of both of these, we multiply them together. Now we can simplify it a little bit more. So 6x times 100 would be 600x times 3x squared minus 4 to the 99th power. Can I distribute inside my parentheses? No, because they have an exponent. If they have an exponent, you can't distribute unless you did 3x squared minus 4 to the 99th power, but you'd be here all day. So this would be our derivative. So you don't have to use substitution every time. The more you practice this, the quicker you'll get with it. What we're essentially doing is taking the derivative of the outside times the derivative of the inside. So the derivative outside the parentheses times the derivative inside the parentheses. Yes. So the bottom says, do we need the chain rule? So for questions like 1 and 2, we don't need the chain rule. We use the derivative we do the derivative just like we have been doing. For a question like 3, where we have those parentheses with an exponent, we have to use the chain rule. So for 1, our derivative would be what? Perfect, 3. What about for 2? 7x to the power 6? Yep. For number 3, let's use our chain rule. So I'm going to take the derivative of the outside. So just pretend that the inside was just one thing. It's just u on the inside. So the derivative of the outside would be 7. Inside the parentheses, we keep it exactly the same as it is. So x plus 1. Now to the 6th power. And we multiply that times the derivative of the inside. What's the derivative of the inside? 1. So our derivative would just be 7 times x plus 1 to the 6th power. Because when we multiply it by 1, it's the same. All right, let's look at 4 up at the top. So again, we're going to do our chain rule here. So the derivative of the outside, would be 7. The inside just stays the same when we take the derivative of the outside. So 7 times x squared plus 1. What's our exponent on it now? To the 6th power times the derivative of the inside. What's the derivative of x squared plus 1? 2x. We can do a little bit of simplifying here. 2x times 7 would be 14x. So we have 14x times x squared plus 1 to the 6th power. We can't distribute inside the parentheses because it still has an exponent. So it's always the derivative of the outside times the derivative of the inside, which was the derivative of this. Any questions here? All right, example 1. So we have to use our chain rule here. We're going to take the derivative of the outside. What would our derivative of the outside be? 4. You can call it u, but we're just going to replace the u with what's in the inside. So the inside stays the same. X cubed minus 2x plus 28 to what power? To the 3rd power. Times the derivative of the inside. What's the derivative of the inside? Three x squared minus 2. Perfect. Now we can simplify this a little bit more. We can multiply 3x squared minus 2 times 4. So 4 has to be distributed into our parentheses. So that would be 12x squared minus 8 times x cubed minus 2x plus 28 cubed. Does the 12x squared minus 8 need parentheses, or does it not matter? What do we think? It does need it, because that's a binomial there. They're attached. If we didn't put the parentheses, it would just be like as if negative 8 was being multiplied to x cubed minus 2x plus 28 cubed. So you need the parentheses. So this is our derivative. This one is just what we're used to. What would the derivative be here? 6x to the 5th power. All right, example 3. When we take the derivative here, what would we have to do? The product rule. So our product rule is the first times the derivative of the second plus the second times the derivative of the first. So we'll call this will be our F, and then this one will be our G. So our first is 2x minus 3 times the derivative of the second. Well, the derivative of the second, we've got an exponent on it, so we have to do the chain rule. So we're going to start with 3 times the inside stays exactly the same, x squared minus 5 to the 2nd power, times the derivative of the inside. So their chain rule is the derivative of the outside times the derivative of the inside. What's the derivative of x squared minus 5? 2x plus the second times the derivative of the first. So our second would be x squared minus 5 cubed times the derivative of the first. What's 2x minus 3? What's the derivative of that? 2. So let's do some simplifying. So in our first term here, we've got 3 times 2x, which would be 6x. I'm just going to rewrite it here. And then we would distribute this to our parentheses that doesn't have the exponent. So 6x times 2x would be 12x squared minus 18x times x squared minus 5 squared plus 2 times x squared minus 5 cubed. We can simplify a little bit more looking at our 2 terms that we have here. So we've got 1 term here and 1 term here. Do we have a GCF? What? X squared minus 5 to the 2nd power. Perfect. So x squared minus 5 to the 2nd power is going to come out. What we're left with on the inside, we have 12x squared minus 18x plus, if I have, well, 2, x squared minus 5 to the third power, and I take away x squared minus 5 to the second power, what do I have left? X squared minus 5. We can simplify a little bit more. Let's distribute our 2. So this would be 2x squared minus 10. And then inside of our brackets here, we can combine our like terms. So we've got x squared minus 5 squared on the outside. And then 14x squared minus 18x minus 10. So this would be our derivative. We could simplify this a little bit more. This would be perfectly fine on a test. But if this was like a multiple choice question and it simplified it a little bit differently, make sure you know that it could look different. So we could, do I have a GCF in my second term? What? Here, do I have a GCF? 2. I could take out that 2 and put it on the outside. So 2x squared minus 5 squared times 7x squared minus 9x minus 5. So these are the same thing. They're both correct. I don't really think web assign you'll have to take out the 2. I think you could just leave it like the first one. But if this was a multiple choice question and only the second one was your answer, you have to know that you can simplify the first one a little bit more to get the second answer. Some people on the quiz didn't simplify to find the right answer, and they just put none of these. He wasn't the only one. So example 4. We want to change this to be an exponent. So we have y equals 5x squared minus 1. What would our exponent be here? The 1/2 power. Now we can do the chain rule. So 1/2 gets multiplied on the front. We've got 5x squared minus 1. The inside stays the same. We subtract 1, which would give us negative 1/2 as our exponent. Then we multiply that times the derivative of the inside. So we take the derivative of the outside, the inside parentheses stay the same, but then we have to multiply it to the derivative of the outside, or the inside. What's the derivative of 5x squared minus 1? 10x. We can simplify this a little bit more. What is 10x times 1/2? 5x. 5x times 5x squared minus 1 to the negative 1/2 power. Or we could write it a little bit better. Say 5x over 5x squared minus 1 to the 1/2 power. Or we could say 5x over the square root of 5x squared minus 1. So all three of these would work. They'd be the right answer. I think WebAssign might want it this way with the square root. For now, no. WebAssign, you don't have to rationalize. You can leave it like this. So I'm going to say for now, don't worry about rationalizing. We'll practice more. If on a test, I'd be okay with this. The concept really is whether you guys know how to rationalize, but how to take the derivative. So I'd be okay with leaving it like this. All right, let's do example 5. So the derivative of the outside, what would the derivative of the outside be? 7 times the inside, so the inside stays exactly the same. To what power? To the 6th power. Times the derivative of the inside. What's the derivative of the inside? 3. We can multiply 3 times 7. We get 21 times 3x plus 1 to the 6th power. All right, example 6. So what should we do first here? Make it an exponent. So 25 minus x squared to the 1/2 power. Take the derivative of the outside. What do we get? Perfect. So the negative 1/2 power times the derivative of the inside. What's the derivative of the inside? Negative 2x. Awesome. Let's simplify. What's negative 2x times 1/2? Negative x times 25 minus x squared to the negative 1/2 power, or we would say negative x over 25 minus, I'll say the square root of 25 minus x squared. So either way of these would work. Seven. How would we take the derivative? Product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first is 2x plus 3 to the 4th power times the derivative of the second. What's the derivative of x minus 1? 1 plus the second, so x minus 1, times the derivative of the first. What do we have to do to find the derivative of the first? Chain rule. So take the derivative of the outside. We get 4. The inside stays the same. 2x plus 3 to the 3rd power times the derivative of the inside. What's the derivative of the inside? 2. Let's do some simplifying. So we have 2x plus 3 to the 4th power plus, here 4 times 2 would be 8. And 8 I'm going to distribute to the x minus 1. So I'll make it 8x minus 8 times 2x plus 3 cubed. We can simplify this a little bit more. Out of our two terms, do we have a GCF? What's our GCF? 2x plus 3 to the 3rd power. Perfect. So I'm going to take that out. We're left with 2x plus 3 to the 1st power plus 8x minus 8. Inside of our brackets here, we are just adding and subtracting everything. So we can just combine our like terms. So 2x plus 8x would be 10x, and 3 minus 8 would be negative 5. So 2x plus 3 to the 3rd power times 10x minus 5. Can we simplify this a little bit more? Yeah, how? We can take out our 5. So we have 5 times 2x plus 3 cubed times 2x minus 1. Either one of these are fine. They both would work for a test, but if it was multiple choice, it may be simplified one way or the other. All right, example 8. Take the derivative. How would we find the derivative? Well, what would we do first? Let's do the chain thing. 2 goes to the outside. The inside stays exactly the same. We have 3x minus 1 over x squared plus 3. What's our new exponent? 1 to the 1st power. Times the derivative of the inside. What do we have to do to find the derivative of the inside? Our quotient rule, low d high minus high d low over low squared. So our low is x squared plus 3 times the derivative of what's up high. What's the derivative of our numerator? 3 minus what's up high, so 3x minus 1 times the derivative of our denominator. What's the derivative of our denominator? 2x over our denominator squared. So x squared plus 3 squared. Let's do some simplifying. I can distribute the 3, distribute the 2x, and distribute the negative. So I'm going to do a couple steps in one. We've got 3x squared plus 9 minus 6x squared plus 2x. I'm going to combine my like terms. So this would be negative 3x squared plus 11x. No, plus 2x plus 9. Over x squared plus 3 squared times, I can distribute the 2. Let's do that. We'll simplify here. So this would be 6x minus 2 over x squared plus 3. When we multiply with fractions, our numerators get multiplied together and our denominators get multiplied together. So up top, I've got 6x minus 2 times negative 3x squared plus 2x plus 9 over, what's x squared plus 3 times x squared plus 3 squared? X squared plus 3 cubed. This would be fine as an answer. What else could we do to simplify it? I can FOIL out the numerator. But this works for now. But we're going to do one more example. Oh, example 9. Let's say we have 1 over 2x plus 4. 2x plus 3. What would we do here? You can totally do low D high. That will work. It'll give you the same answer. Or we could change this to be 2x plus 3. What would our exponent be? To the power of negative 1. And then we could do our chain rule. So I think doing it this way and doing the chain rule is easier than low D high, but you'll end up with the same answer. So you can do it either way. So this would be negative 1. The inside stays the same, so 2x plus 3 to the power of negative 2. What's the derivative of the inside? 2. So then here we would simplify it as negative 2 over 2x plus 3 squared. So that would be our derivative.